So everyone is trying out the first one on your own. I'll walk around, see how you're doing. How you get into the givens to the proof, right? Oh boy, we got some work to do here. Where does it say bisector midpoint? Anywhere? Anywhere?
No.
Okay, so we're not using that. We're not using that. How do I go from here to there? Am I getting bigger or smaller? All right, it's, we're separating ourselves here from where we need help and who's where they need to be. Okay, we're separating ourselves. No problem. But my rule is, if you have extra steps that are correct but not needed,
I was trying to do that. I was going to subtract from.
Okay, here we go. Real quickly, majority of us, excellent. Where I need you, and again, this is, I'm gonna be a straight shooter here. This is a basic one. This is basic. As I go from AB to AC, that segment is getting longer. That tells me to add. I first say to myself, all right, do I have two quantities? 1, 2, yes, I do. So statement 2, you can add those up. AB plus BC, same as ED plus DC, that's addition. And then as we end it, always substitution. Okay, substitution. All right. Let me just let you in on the conversation I had with Catherine about a minute ago. She had an extra step in here, which was correct, but not needed. I'm never going to mark off for it. Okay? If you have an extra step in here, that it's got to be correct, though. Even though it's not needed, I'm not going to take off. You might have a reflexive in there you thought you needed. So maybe you have BC equals BC, CD equals CD reflexive. It's still, that's a correct statement. Did I need it? No. I'm not going to take off, though. Okay, everyone good with that? If it is if it's a wrong statement, though, incorrect, I got to take off. Everybody good? Hopefully that's a little wake-up call for a few of you. Hey, maybe I'm not where I need to be. I got to get my act together because I'm moving on. Questions? All right, here we go. New proof. New type of proof here using a new fact. You guys know the deal. Don't wait for me. Mark your diagram. I'm still nervous if we know where these angles are. I got a symbol up there, right? A symbol we've discussed over and over again, so hopefully we know what that symbol means. And what to do with it on our diagram. What does that symbol mean again, and how do I use it on my diagram? As you're working there, I'm going to call on a few of you here. What is that symbol in between CD and AB again? What does that symbol mean? That's why I have numbers to call on everybody. Where are we going? Kevin, what's that symbol? Perpendicular. What are you guys thinking when you hear the vocabulary term perpendicular? What are you guys thinking there? Let's go, Catherine. What are you thinking? A right angle. Perfect. Great work. Where is my right angle? Wherever CD and AB meet. So we should all have a right angle symbol here, here, or both. It doesn't matter. We know both of them are a right angle, even if you only put one of them. Also, we should be putting a right angle symbol at ACB. That's a right angle. ACB. So we should have a right angle symbol there. Can everyone find that angle? Because hey, if you can't mark your diagram, good luck in the statements reasons, right? Good luck. All right, everyone all right with their markings? We got whatever we got all the givens in your statements reasons. Now look at the proof statement so we can talk. ACB, find that angle right now. ACB, find that angle. And find angle ADC. Anybody want to tell me anything you know about those two? What do you notice about them on your diagram? What are they? They're both right angles, aren't they? Everyone has both those angles in the proof statement marked as right angles. What do you know about right angles? They're 90. They're equal to each other. So that makes sense that those angles have to be equal. It's just a matter of how do I write everything correctly in the proof. But does everyone see the idea? Both those angles are right angles. So of course they have to be equal to each other. They're both 90. And what we're going to do to show that they're equal is our new fact here, and our only one for today, which says all right angles are congruent. That's what we're going to show. But it's not going to be 2 steps, though. I have a requirement if you're going to use that fact. So right below where it says theorem, all right angles are congruent, write a little note for yourself going forward. You cannot use this whenever you want. Here's the note. Must state you have right angles before using. Okay? You must state you have right angles before using this. So if you want to tell me, I'll let you write it down and explain. If you want to tell me 2 angles are congruent because they're right angles, in your statement somewhere, you need to actually write that they are right angles first. And I don't have that yet. I want to show these 2 are right angles, but how many did I already tell you? It's actually a right angle. Only one of them, right? And that's ACB. I still need to tell you ADC is actual right angle before saying they're congruent. So does everyone see what I mean by my note here? If you want to tell me 2 right angles are congruent, fine, I get it. But up above in your statements, you actually need to tell me why they're right angles. And I only did that for one of them. We still need to tell you that. What's my other one I still need to say is a right angle? ADC is a right angle. I still need to tell you that one's a right angle. In your own words, how did we know that it was a right angle? Why did we put the symbol there, right? Why did we put the symbol? And I got something specific I want to write that I wrote down on day 1 of this unit, and I know nobody remembers, and that's perfectly fine. How did we know to put a right angle symbol there, Jacob?
Perpendicular line straight right angle.
Okay, that's kind of what I'm going to write there, yeah, because it was the perpendicular symbol, right? So reason, perpendicular lines form right angles. I'd like you to use this reason every time you say it's a right angle. And this is on you. This is not something I'm going to post over there or it will be available on test day. That's something you got to remember. All right? All right, did I tell you both of them are right angles? Okay, check. Now I can tell you they're congruent. See what I mean? You got to tell me both of them are right angles first before you tell me they're equal to each other. So now angle ACB congruent to angle ADC. And that's using our new fact for today, which if you want to get 2 right angles congruent, all right angles congruent. But you got to tell me they are right angles first above. You need to state that they are right angles. Where are they? Anything you want to ask here before we go on to the toughest proof so far to date? Are you ready? Are we ready for this?
Yeah.
You think you're up for it?
Yep.
Let's see. This will be your toughest and longest proof to date. First battle, can you mark the diagram correctly with the givens? That's the first battle. If you can't win that battle, see ya. Nice markings. Nice. Again, guys, if you can't mark your diagram, you need help. Okay? Straightforward with it. You need help if you can't mark your diagram here. I got that darn symbol again, and 2 angles congruent. No hash marks on my diagram here. All right, not bad. Many of you, not bad. Again, if you need help if you can't mark the diagram. All right, people are blowing by you. All right, take a look. A to B to C. B is in the middle, so that means it's the vertex. Where's that angle? Okay, yep, now find the other angle. Everyone, take a look. We should have had a right angle here and a right angle here. That's what the perpendicular told me. And we should have arc marks on angle ABC and angle FGE. So that's where my arc mark should have been. We ready to tackle this proof? All right, let's look at the proof statement. What am I asking you to prove true? Angle DBC. Can you find that? Don't mark it because we don't want to mark the proof statement. Everyone see where angle DBC is? Right next to the one of the congruent angles? Right here. Everyone sees that angle there? And DGE. Everyone find that angle? Right next to the other angle we marked congruent? All right, how are we getting those two? Now remember, don't make up stuff. We only have so much available. And can I eliminate one of them right now? Anybody see bisect or midpoint? Okay, so that's not available. So this is what we have available to us here. Nothing else. Right? So I don't want to start making up our own thing here. So look at your markings on the diagram and where we need to go. So if I just look at this side over here, this triangle over here, I mark the right angle in this one and I need to get to that one right there. How's that going to get done? How's that going to get done up there? What do we think? Think about it. I got the right angle marked and I got this congruent angle marked. And I got to somehow use those two to get to that one. That's all you have available as well. Tess, what do you think? What do I have to do? Maybe. Subtraction? Take the right angle and subtract the one you marked. What angle do I get? The one I need. Take the right angle, subtract the one I marked. I'm just making a mess, but you get the one you need. See how this is subtraction? I'm going from the right angle to a smaller one. Everyone are good on subtraction. So at least we found it was a subtraction one. Good job, Tess. What am I going to ask you guys now? And what do I always ask you if you say subtraction or addition? What's my next question? How many pairs do I need? 2. How many are listed in the givens? 1. Right? Only 1 pair. And I know, and I've got you brainwashed, which is great, that you think that second pair has always got to be reflexive. This is where that ends. That's where this ends right now. The second pair will not be reflexive. What are you subtracting this pair from? The what? So I need those congruent first. That's your second pair of the right angles. Make sense? The one pair is right here. The second pair is not a reflexive pair. It's going to be your right angles. So I need you to get the right angles congruent first. All right? So I need to get the right angles congruent. What do I need to say first then? I can't say the right angles are equal yet. You made a big note above. Violet, what do I still need to tell you? Where are your right angles? If you're going to say right angles are congruent, where are they? Violet, one more time. What are they? Angle perfect. Angle ABD and angle DGF are right angles. And you guys already have a reason why. Look above, and that's going to be no definition here. Perpendicular lines form right angles. Once you tell me where they are, now what can you tell me about them? All right, I have right angles. Now what do I know about them? They're congruent. That's like going to be like a two-step process every proof. Tell me they're right angles, then in the next step, tell me they're congruent. All right angles congruent. Now how many quantities do I have? How many quantities do I have now? Congruent quantities, pairs. The given and the one we just wrote. Now what can I do? Now I can subtract. Right angle minus the given angle. So angle ABD minus, what am I going to subtract from ABD? ABC is the same as, and none of this is different. None of this is different. FGD, the other right angle, minus, what's that other one? FGE. Subtraction. Make sure we're writing subtraction, right? Not the other word. That sounds like it. And nothing's changing. What's always after subtraction? Substitution with the proof statement. Oh, look at you guys working your way up to 5 steps now, huh? Look at you. Boss moves. DBC, DGE. Boss moves. 5 steps. So you guys figured out it was a subtraction proof. All right, you figured out it was subtraction. You said, how many pairs do I need? 2. I only had how many? 1. And instead of the other pair coming from a reflexive pair like it used to, now it came from right angles. The other pair were right angles now instead. Like that. Questions? All right, the next one. I could have assigned this one last night to you, which means I'm going to come around and watch you do it. Okay, I could have assigned this one last night to you. This is just a review proof. Come on, get yourself off to the right foot. You see what in the givens? Bisect. All right, you should know how this proof's going to end. You should know how this proof's going to end. It's just a matter of what's in between it. If you want to talk it out with people in your group, that's fine too, and make sure you're all in the same steps and pages. right, you said you saw the word bisects. What's going to be the last reason in this proof then? It's automatic, right? At this point, I don't know what step it's going to be, but I know the last reason is going to be what? Halves of equal quantities. Yep, that's going to be my last reason because I see bisects. But you know better. You still need to tell me what before you write that last statement. Because I didn't write it up in the givens for you. Well, you got to tell me what you're cutting in half, right? So probably in step 2, you're going to tell me what you're cutting in half and what you're calling it. All right, can we do this? Again, you want to compare it with your group, you can. It's up to you.
Skip. You can read it.
Guess you haven't done enough of these, huh? For some of you, haven't practiced enough. Not taking the homework seriously, maybe. Guys, it's going to burn you next Monday. Okay, because all I'm going to do is give you a quiz or a test with about 5 proofs on it. And say, here you go. All right? I don't think some of us might be wanting to take the homework a little more seriously. Here you go. Statement 2. What are you taking half of? Well, I'm taking half of angle EAB because it says it's getting bisect, and I'm going to call that angle 1. Why don't I call it angle GAB? You could, but it's not in the proof statement. I want angle 1. And also, I'm going to take half of the other angle that's getting bisected, FBC, and call that angle 2. And that is, I know what a bisector means. Bless you. Definition of a bisector. Once you tell me what you're taking half of, I know the halves have to be equal to each other. Again, this is not algebra 2 or algebra 1. I don't care how you did last year. I told you that on the first day of school. This is a blank slate. Just because you might have been a stud in algebra 1 doesn't mean your same work ethic will make you a stud here. So what's that? Halves of equal quantities are equal. And I think all of you know deep down where you stand. Okay. Some of you know you're right where you need to be. Some of you know I'm in trouble. We all good? All right, last part here. This is the good news for some of you. Given, right? RST and SQ are perpendicular. What are you putting where those two meet? Should be a right angle symbol. Only one, though. Right? Where RST and SQ meet, I should have a right angle. And now I'm telling you angle RSU, 89 degrees. Okay, 89 degrees. All good? Now, here's the catch, and some of you are going to like this a lot better. Notice the directions now say find and not prove. That means I don't need a statement's reasons here. It's just find these angles algebraically. Okay, so I don't need a statement's reasons unless it says prove. It's fine. I know a lot of people go right to it. That's what we've been doing. But if it says find, just find it. So measure of RSQ. Take a look at your diagram. What is the measure of RSQ? How many degrees? 90. Now, here comes the part you might not like. See what I have over there in bold. Why'd you write down 90? That's what I want to know. I'm not looking for anything specific. I need to know why in words you decide to put 90 down. Why didn't you put 10, 15, 80, 62? Why was it 90 that you put down there? Why? Just something in your own words I need written down. Henry, go ahead.
Right angles.
Right angles equal 90. Perpendicular lines form right angles. Definition of a right angle. Something that you can tell me, hey, Mr. Carlino, this is why I put 90 here and not any other degree measure. All right, so I will leave that to you. I'm not looking for anything specific, but when the directions do say justify, I need to know why. The number alone won't cut it. Next one, how about QST? Angle QST?
90.
Also 90. What would be your own reason there? Jacob, what do you have? Linear pairs are supplementary. Straight lines add to 180. Perpendicular lines form right angles. Okay, something that shows me you know why it's 90. And then finally, how about angle TSU? That is not 90, unfortunately. How do I find TSU? Abby?
180 minus 89.
180 minus 89. I believe that gives you 91. And again, same thing. Why? Why'd Abby pick $1.80 there? Why'd she pick 180? Why didn't she do 90? Kira? Perfect. I love it. Linear pairs are supplementary. Straight lines equal 180. Straight angles equal 180. Okay? Supplementary angles add to 180. But everyone good. When you see the directions tonight that say justify, write me a little why you wrote that number. All right? So I only think it's 2 pages worth. What do I got there? 3. Oh, okay, a couple more algebra problems after that.